So good morning, everybody. I hope you can all find your seats so we can start this very exciting plenary. So welcome on the third day of this Living Planet Symposium. So as you can see, today we're going to talk about the global crisis and Earth action. I think preaching to the choir, so we all know that the world is not in a very good shape. So in the introduction already, we talked about the triple planetary crisis. So as we know, we have that issue with climate change, we have the biodiversity loss, so we have a lot of issues with pollution and also severe consequences also for economy. So what we're going to do this morning, and for this we invited a wide range of real international partners with ESA to talk about how we really can use Earth observation and what we can do to overcome all these different crises. So we're talking about Earth action because we do believe hope is an action. It's not by just watching and monitoring it, but also what can we do. So for this, we're going to have two panels this morning. And the first panel is really understanding our planet. So for this, I'll pass the floor to my colleague, Clément Alberger, who is the head of the Actional Climate Info section of ESA.
Thank you, Inge. Good morning, everybody. Thank you for coming here. Addressing the triple crisis will require a collective effort. And to adapt to our changing environment, to mitigate the impact of this planetary crisis, we need systematic observation of the Earth system. We need to understand, from evidencing our changing environment to Earth action, satellite Earth observation are a fundamental part of the solution. This first panel is called Understanding Our Planet. And I would like to invite on stage Elaine Hewitt, representing the Couple Model Intercomparison project. I also would like to invite Eleanor Blith, representing the World Climate Research Program, WCRP. Martin Herold, in his capacity of chair of the terrestrial observing panel of the Global Climate Observing System. Thank you, Martin. And Grit Manhout from the Joint Research Center. Thank you very much for joining us today. So, to start this panel discussion, I would like to ask each of you to provide an opening statement outlining your expertise related to the planetary crisis, and perhaps already giving a reflection on the significance of Earth observation in addressing one or more of the crises.
Hi, I'm Helene Hewitt. I am a science fellow at the Met Office Hadley Centre, where I've worked in climate science for almost 30 years. I'm now the co-chair of the Coupled Model Intercomparison project. And if you haven't heard of CMIP, if you look at the IPCC reports and see future projections of climate, many or almost all of those figures will have derived from the CMIP project. For the sixth assessment report of IPCC, I was a coordinating lead author on Working Group 1, where I led the chapter on oceans, cryosphere, and sea level change, and also contributed to the summary for policymakers there. And, particularly in climate, future projections are so important for informing mitigation and adaptation actions. And so we might think that Earth observation data was about the past, but it's also really useful for informing the future. So I'll give you an example from the sixth assessment report, where having the Earth observation data to look at the past for how clouds and radiation were linked was able to constrain the effective climate sensitivity of the whole system. And what this meant for IPCC assessments was that we could more robustly constrain projections of surface temperature and sea level going into the future. So this is really critical for the decision makers. And overall, beyond, not just for climate, but for the other aspects of this triple crisis, Earth observation data is absolutely critical for monitoring, and not just of the past, but as we go into the future, monitoring actions that might be taken so that we can actually assess their effectiveness.
Thank you. Eleanor.
Thank you. So I'm Eleanor Blythe. I'm a principal land surface modeller in the UK. And we work with the JULES model, which is part of the UK Met Office suite. So it's part of weather forecasting as well as climate. But it's also used away from all of that to look at food, the impact, the interrelationship between water, food, and carbon. And it can also be used offline to look at hazards such as fire and flood and drought. So my expertise is applying that at the global and regional scale. JULES is one of the complex land surface models that combine all of this, and I just want to read you my 4-point manifesto of why we use models. The point of modeling is to test theories and make predictions, 1. 2, in the next few decades, we'll see new abrupt changes to the weather and climate that will impact the environment. 3, the natural environment is a complex and dynamic system interweaving physical, chemical, and ecological processes. And 4, therefore, we need complex models to answer critical challenges, such as where will water be available, where can we grow crops, and where can we store carbon in a changing climate. These issues have not only climate and weather implications, but economic implications for regions around the world. And this model that we use is used to make those decisions. So the point about EO data and ESA is that the thing is the model doesn't work equally well in all parts of the world. There's a hierarchy of where the model works well, and the model does not work well, for instance, in dry land ecosystems. Dry land ecosystems are not well represented in our model. We need to understand the processes better. And so my concrete example of how EO data has been useful is a lovely study where they were looking at dry land ecosystems and not only looking at the phenology due to the leaf area, how quickly the trees drop their leaves in a drought, but they could also use other data such as soil moisture and also the photosynthesis product, SIF, to see whether the plants were beginning to downturn in a drought before they lose their leaves. This information is absolutely critical to improve the processes in our models so that we can start making the right decisions about our land. Thank you.
Thank you. Martin.
Yes. Good morning, everybody. Martin Herold from the German GFZ Geo Research Center. I'm an Earth observation scientist, and I mostly focus on terrestrial dynamics. I'm here also in the capacity of chairing the Terrestrial Observation Panel for Climate, which is part of the Global Climate Observing System. And I can only agree with what Helen and Eleanor said. A lot of what we know today about where and why the Earth system is changing is from a good set of systematic Earth observation in combination with modeling. So that is our key data source. Without that, we would not be even understanding the crisis situation that we have and that was outlined by Inge at the opening. In terms of significant contributions of Earth observation, I would like to highlight actually a bit of a different point, because I think over the last 10 years we have made significant progress in working with countries, in particular tropical countries, in making use of Earth observation data for their purposes. Almost all tropical forest countries today are using Earth observation in a systematic way to keep track on their forests, on their critical land changes, their carbon stocks, and so on. And that has been made possible through strategic partnerships. So it's not only about providing high-quality Earth observation data that are provided by the space agencies, easily accessible. The open source data policy is fundamental. Having strategic partnerships to work between the space agencies, Earth observation experts, and experts in the countries, both in the science and mandated organizations, to make that happen. And that's what we did. And that's where we made a lot of important progress to put the data on where they matter. Basically, the big advantage of Earth observation in general is that essentially every landmass on the planet, you can go and you have a thick remote sensing Earth observation archive, so you can keep track and look back in time what actually happened to that piece of land. And nowadays, in almost near real time, can track whether new critical changes are happening on that piece of land today. And that's the only data source that allows us to do that. And that is valued not only by us as Earth observation scientists, but also from the various people that can use that information towards actions, towards responding, towards keeping track, and yeah, responding to the crisis situations.
Thank you, Martin.
Good morning, I'm Greet Maanhout, and I'm leading the Forest and Bioeconomy Unit, and as well Deputy Director for Sustainable Resources at the Joint Research Center. The Joint Research Center is the scientific arm of the European Commission, and we have in our role as well of bringing Earth observation data and tools within policies and in policy making. I have been working myself on mapping emissions globally and contributing to the greenhouse gas monitoring, in particular the CO2 monitoring and verification support capacity. And I believe that Europe can still take quite a lot of a lead in showing as well how to, based on scientific data, implement this in policies. And we see an increased uptake of Earth observation data in policies. We see as well how the monitoring systems are pushed towards more near real-time monitoring with Earth observation data. Also, for example, in the LULUCF sector, land use change and forestry, also for the forest monitoring law, we want to stick with Earth observation as key and satellite data as key element of the monitoring law. To come back on the triple crisis and how to tackle that, I would see 3 steps. The first step is, of course, monitoring Earth observation and understanding this. And I think we have had all elements already from the speakers before and from the introduction of Inge on this. It's clear what you cannot measure, you cannot manage. But there is a second step, and that is about the solutions. And we do have solutions. We have renewable energy technologies. We have as well some sustainable practices for farming, for forestry. But we need to monitor as well their effectiveness and their limitations. In particular as well, their shortcomings, their trade-offs, and their Earth observation is very important as well. And the third step, which might be even, I believe, the most difficult step, is enabling these solutions to upscale, and upscaling really at global level. And that you either do with a stick or with a carrot. And in the European Commission, we have, of course, our European Green Deal policies. We have, of course, been using as well Earth observation for environmental compliance assurance, which is then rather going towards the stick for implementing these policies. But there is as well some other policies with the carrot on the carbon farming, for instance, where we are looking into finding with some carbon farming projects and monitoring the effect of extra removal of the carbon into the soil advantages and going ahead. Thank you.
Thank you. It was great to see your keen enthusiasm towards our activity, towards Earth observations. We have also prepared a specific question, and I will first address to you, Helene. At ESA, we are hosting the CEMIP International Project Office, giving more strength to our activity towards the modeling community. For you, how do you think that our activity could advance the goal of CEMIP 7, the next big chunk of activity, particularly in delivering actionable climate information for decision makers?
First of all, can I just start by thanking ESA on behalf of the World Climate Research Programme for its support of the International Project Office. It has been a real step change for the modelling community to have this support with a fantastic IPO who I think are probably good enough at managing CMIP like a satellite mission. So it's fantastic work. But beyond that, having that collaboration with ESA has really moved forwards the interaction on the observation and modelling interface. And there's, we can highlight two particular areas. First of all, one thing that's really critical for modelers is to be able to accurately model the past. And to do that, we need the historical climate forcings. So these are all the external drivers which determine the climate, whether that's your greenhouse gas emissions, aerosols, biomass burning emissions, volcanic or solar, for example. And so we've worked across the community, but with the support of ESA, to bring the best observations to that problem. And so, of course, as modelers, we want to look right back to the pre-industrial. Satellites did not exist then, sadly. But bringing that insight from the satellite era, so the higher resolution, both spatially and temporally, to the pre-satellite era, has really improved those forcings. And just as an example for why this is really important, 2023 and 2024, we saw those as, everybody knows they were exceptionally warm years. But because we don't have yet the consistent data set of what drove climate over those years, we cannot definitively answer that question. And so we hope that with the CMIP community and the ESA support, this will move forwards. And the second really important area for Earth observations in that is the evaluation and benchmarking of models. We've worked with the ESA and the communities to implement a rapid evaluation framework so that for IPCC we can give lots of metrics on the climate models and how they perform for the recent past and the present day. And I can't underestimate or can't emphasize enough to you how important this is when you're talking to decision makers, because if they don't believe the models, they don't believe what you tell them about the future. So without the observations, we wouldn't be able to do that ground truthing. So so the collaboration with ESA has been, really important for CMIP 7's progress.
Thank you. Eleanor, you're also an expert terrestrial modeler. What would you say are the main challenges faced by your community, and what perhaps are the observation gap that needs to be addressed?
Thank you very much. What a lovely question. So what we're finding in the terrestrial community, we go to a lot of meetings where there's a push to get to finer and finer resolution of the weather system models. The Destiny E, I think, is getting finer and finer resolution and coming down to be able to do weather forecasting at 1 kilometre and so on, which is quite exciting. But for the land community, that's not quite our problem. We don't really have a space problem. We have a process problem. Because one of the biggest drivers of the climate system on the land, and I'm going to come back to ecosystems, is the ecosystem response. So the ecosystem response to long-term changes in temperature, long-term changes in the atmospheric CO2, short-term changes in the rainfall, and so on, is our issue. And where Earth observation products are incredibly useful are in the data-sparse regions of the dry lands of the world. So as I said before, the models work quite well in the temperate zone. And it's not surprising. The people who coded it up, which is me and my colleagues, say 20 or 30 years ago, we did it from our imagination. Our understanding of how the world works is now written in Fortran. That's an expression of our understanding of the world. And not surprisingly, it doesn't work so well in some areas of the world. I was having a meeting with a friend of mine who's from Australia and a friend who was brought up on the border with Mexico. And so the American guy said to the Australian, so how are things there in the UK? And he said, it's weird, he said. Well, I won't do an Australian accent, it'll come out wrong. It's weird, he said. It hasn't rained here for 3 months, but it's still green. And the two of them laughed and laughed and laughed. And I said, what do you mean? What's funny about that? And they said, well, it wouldn't be like that in Australia or the dry lands of America. And we kind of, I mean, maybe if you live in those regions, you know perfectly well that that's true, because the vegetation, they said, well, the thing is, the vegetation will quickly go brown and dry down and store its chlorophyll because it might not rain for another 10 years. Whereas in the UK, where we were writing the code, you know, in an office in Bracknell or something, we're used to our vegetation that is expecting rain, at least in the next few months. So we need more information about how ecosystems work in areas of the world, and it's absolutely critical for the economies of those countries. I'll just give you an example. Again, for sub-Saharan Africa, I know, because I was visiting recently, that in Kenya, they've promised to plant 1 billion trees. And there's finance around that. And, but what, you know, will those trees still be there in 30 years' time? The climate is changing. Do we know enough about the ecosystems of these countries to know whether they are going to be, if that's a reliable climate mitigation strategy? So that's where we need more information, is how ecosystems respond to slow and fast environmental change, and that's where the Earth observation data is really valuable. Thank you.
Thank you very much. I will not keep only that, but you don't have a space problem. I like it. Martin, what would you say in your domain are the most significant advances in Earth observation that have happened in the past decades that have supported climate, but also conservation-informed decision-making?
I would like to actually directly come back to what Eleanor just said, and also at this conference, particularly for ecosystem dynamics and keeping track of that. I mean, there's a lot of important progress that I think we see here that is driven also by observational progress. So both in terms of getting into structural and surface dynamics, you know, we see also the first image of biomass here, right? We have spaceborne LiDAR, but also on the spectral, so a lot of hyperspectral is actually here, CHIME is coming up. I mean, so this combination of structural and biogeochemical tracking of the ecosystem is much, much improved now than just a few years ago, and I think that will help you and us to get in that direction. But I'd also like to pick up on the long-term systematic observations representing the Global Climate Observing System, who is working with the UNFCCC, the UN Climate Convention, directly to keep track on research and systematic observations for the overall goal of the convention. And that system, in defining what is essential and important in terms of climate variables, what are the specific requirements that can be posed to the observation community to develop a systematic system for the atmosphere, the oceans, and the land as part of a global system, that has been quite successful in terms of GCOS providing the requirements and the monitoring programs, the agencies that are in a position to do so, to pick that up and really put it in place. And I think that is a very successful model that has worked and over the last years, and we really see this now flourishing, basically looking at, for example, the ESA Climate Change Initiative, looking at the Copernicus services, but also looking at the contributions of our other global partners that are part of this global climate observing system. And of course, there are still gaps. The GCOS publishes every 2 to 3 years a report that looks at what has been achieved, but what are gaps left. But we also have to realize that at the moment, with some things happening on the other side of the Atlantic, is that we might see gaps again in the global climate record that we have thought we had solved over the last years, right? And that is, we are basically taking a step back, and the global climate observing system is struggling in parts. And that's also something that we, I guess, at the European conference have to say, that if some partners are not in a position to keep up their global mandate for whatever reason, that others are able to step in and really keep it up as a global system.
Thank you, Martin. Perhaps already thinking about the second part of this plenary policy, which international or European policies related to the triple crisis should benefit the most from Earth observation?
So let me first say that we have seen this huge increase in mentioning of Earth observation and Copernicus in policy documents. So when this was only 11 documents that we found between 2015 and 2019. From 2020 to 2024, these are 87 references that you can really nail down in policies, in delegated acts, and so on. However, this is not everything, because in the end, it are the member states who need to bring these policies within their national law. And they need to take this up within their national inventory agencies, their forest inventory agencies, for instance. And we have there a lot of statistical inventory compilers. We all love data together, but there might be, when there is not too much involvement in the process of certain Earth observation or Copernicus products, there might be some hesitance for taking them up just like this. So we are working in the GRC around the entire policy cycle, and on the anticipatory side, so shaking up, waking them up, that with Earth observation near real time, it's there. We can see harvesting, as we have demonstrated in a paper, before they see it in their inventory. But also for implementing them, so we are working on capacity building. We have, for instance, the European Forest Science Partnership, where together with all of you, we want to build on an increased capacity also in the countries for scaling that up. And to come on your last point, for which policy I would see now the most suitable for doing this at global scale, this would be for me definitely the greenhouse gas monitoring. It is the most diluted, so directly diluted globally. You need a global effort because it's a collaborative effort that you need. And we do need to talk as well all the same language. So to be able to refer to the situation with one monitoring system that is accepted by everybody would be of an advantage without having then problems in discussing what needs to be done. And I'm having great hope for the CO2M when it comes there in 2027, which will not monitor only greenhouse gases. I believe we will see the huge biospheric pumping and also their changes, and maybe we see there as well some onset of some tipping points where some nature systems are not anymore absorbing the CO2 like we wanted to have them doing that before. So that is what I see as an interesting part.
Thank you. Our last round of questions will be looking forward. How can data provider, Earth observation data provider, ESA, can better support our understanding of the triple planetary crisis? Eileen.
Well, first of all, my first ask to Earth observation providers is to maintain the long records. We've seen it's so powerful when you talk to policymakers to show those long records. For example, with Cryosat and the sea ice data, that's been so critical. And we don't see that in all communities. It's much harder in the ocean community to make the case to continue long records of the deep ocean and rapid arrays of the meridional overturning circulation. So that's my first ask. And it's important because it may also monitor the tipping points, for example. And as we move towards modeling the world with artificial intelligence methods, they have to be trained on data. So that the long records are going to be really important. But more than that, I would really encourage you to innovate as well, because we will use the data in many ways that we haven't even perhaps thought about at the moment. So, for example, our models are moving to higher resolution. We want to see the processes on the smaller scales and the interactions between the processes. There's existing records that can continue to be made use of. So, for example, there was some great work done in building an ocean acidification record from long-standing satellite records along with AI. And my final thing is, I think there's real opportunities to work across these areas of the triple crisis. So in AR6, for example, there was a lot of talk, not just about mitigation, but also about reducing pollution so that we can improve air quality. And so these co-benefits are really important.
Thank you.
Thank you. Yeah, I thought about this. This is a really interesting question about how to take this forward. And I think all the pieces of the puzzle are there, but I do think that there's, I think we're a slightly split community for the terrestrial side. I think there's the Earth observation and the modelers. There are some people that use Earth observation to benchmark the models, but I think to really use the Earth observation to understand the processes in the models, I think we need to work a bit better together. The papers I see from the Earth observation community are all about Earth observation, and they might show they've found some cool new phenomena, but then they don't check whether we kind of already knew that. Maybe the models, I mean, the models are based on a shared theory about how the land works. And what's important is to find out where that theory was wrong. You know, we didn't get that right. And the Earth observation data is so well designed to be able to look at these processes, but we don't quite bring that together. Now, in this next summer, we have an international forum for land modelling called the International Land Modelling Forum. And the modelers all get together and we all scratch our heads and say, what are we going to do about this, that, and the other? And there's a lot of software issues and benchmarking and so on. And actually, next year, we're actually hosting it at ESA. So ESA are going to be hosting the modelling groups. Now, I think that could be the beginning of a closer relationship so that the Earth observation people ask the modelers, what do you need? How can we, you know, what kind of versions of our data would be useful? I have one example where the Earth observation people were providing a soil moisture product. And they said, here's a soil moisture product, go and use it, it's fantastic. And we've got all the answers. But it doesn't work where there are trees. And I said, well, actually, I don't really need soil moisture. I mean, soil moisture is not too difficult to model. The thing that's really hard to model is interception, when the water lands on the tree before it evaporates. That is really hard to get data on. And you've gone and said you haven't got the data over the trees. And they sort of went, well, actually, we have got the data. We just we couldn't call it soil moisture, but actually it's probably the right product for you. So a conversation needed to happen between the EO people who'd said, we've got to deliver soil moisture, and therefore it doesn't work over trees, and actually the modelers didn't necessarily need soil moisture, they needed interception rates. So more conversations, please, more meetings like this, but you know, I'm looking at the discussions, whether there's one where the modelers can put up their wish list of what processes they're interested in. I think we need to work better together.
Yeah, thanks. From the observation side, I think one key step we have to take more serious is to really integrate what we measure from space with what we measure from the ground. Maybe it's an obvious thing. I mean, we know that before, but when I think about the Copernicus expansion missions, I think about the next Earth Explorers, I think about the Sentinel next generation, we're getting to such a level of quality measurements in detail that are hard to value if you cannot underpin it with good measurements from the bottom up. And I'm not talking about having a few observations to calval what we see from space and vice versa. I'm thinking about complementary data streams that can really study phenomena in a more integrated way. And that will help us to get also more better locally. A lot of global products that are being generated, they work reasonably well at a certain aggregated level. But we were serious about to take it more actionable or really make it relevant for any kind of local stakeholders. There's an additional step needed, and having this in situ data integration is going to help us to take that step.
Thank you, Martin.
Thank you. I fully agree with integrating the top-down and the bottom-up data streams. I think this is very, very valuable and will lead to a lot of good results. I would add just that we need to keep as well the reference to what is really measured, what is really the reference and the authenticated measurement. So with artificial intelligence, we will tap into many information and data sources. There are many portals. We have already at the GRC, the Knowledge Center for Earth Observation. We have the EU Forest Observatory. And then there are all these institutes here which have all their portals and information. IA will tap into that. But to have the reference right and to know what is really what has been measured, this is a very important asset that we will need as well.
Thank you very much. it's already time to close this first panel of this plenary. Thank you very much for all this information. That was very insightful. I even took notes. So now we're going to put that into action. Thank you very much. And with that, I invite Inge to come back on stage.
Time. And so I'm also happy that we're following the steps Greet just proposed. So we now know how the planet works. We know to monitor, to manage, but let's also look into how to enable. So for this, we're going to go from science to policy and beyond. And I'm very pleased to invite a panel. So I would like first Fanny Caliano de Jong to come. So she's the principal manager of the European Bank of Reconstruction and Development. So you can take the seat. Then we have also Herman Ludwig Müller. He's the director of the European Space Policy Institute. We're very pleased also to have Renaud Seligman. He's the director for strategy and operations of the Planet, the vice presidency from the World Bank Group. We have Dusan Schrenek. He's the principal advisor from DG Klima. Dusan. And then, last but not least, we have David Aubrey, the Regional Director for UN Habitat for Europe. So as Greet was saying, so we go beyond the science, and I heard already the comment from some people. So LPS used to be a small unit, a small meeting. We had only had scientists, but look how an amazing panel we have here. So to go beyond, a bit like Eleanor was saying, we have to work more together. So I think Isa did the job to really bring these people together. So we're going to share with you now a bit how we can do this. So in order to set the scene, we're going to first give the floor to Ludwig, who is the director of the European Space Policy Institute and who has worked extensively, I would say, on how to bring this in policy. So Ludwig.
Yes. If I can use the podium for a minute.
It's a free country, so you can do
so
what you want.
I will start from the end, and the end is really that we are going public with something that we just are issuing as we speak on the ESA and on the SB websites. It's a policy vision for Earth observation. So you're invited to consult this. I go and start from the beginning, and the beginning was really in 1991 for me, when ERS-1 was launched in May. I had a 1-year-old son sleeping in my office in the launch night, and then there has been an ENVISAT, there has been MSG, there has been a few Sentinels along the way. And we really jump into something now where, from the supply side, we do a lot of stuff, and I've been there with you, to put these systems in space, and we continue to do so. But really maybe to have a bit of a paradigm shift to really go into something that is much more on the demand pull. We do it, and it was mentioned also from JRC, there was an intervention, 87 references in different policies, and how do we do this in national policies, but I think this is really the beginning. And if you ask me today, as somebody who comes from the supply side traditionally and now today is on the policy end, we are at 20% of possible impact if we really get this going. So this is an announcement of an effort that not only we did with ESA and SB, but with a group of external stakeholders, which we brought together in London at the Royal Society. And there are some, and not only you, but as is so great, there were people in this setting, and I'll come back to this in a moment. So there was a mention of a split community a minute ago between modelers and Earth observation community. I think we have a split community still between Earth observation space at large and the politicians. And I think this is really what we want to overcome. And when we say this, to bridge between space and policy, this is not only the politicians and ministries and parliaments, it's not only European and national level, it's also the businesses, it's also the private side. And if you think we are the center of the universe as Earth observation and space, the answer is no. I think we are living maybe the Galileo moment. We have digital on one side, that's 100 times bigger than us when you talk the Amazons and the likes. We have security and defense and governmental requirements stepping up enormously today. And that is also 100 times bigger than us. And I think we need to find our place in this planetary system, if you want. And we are probably not the sun in this, so we need to really balance this. And Ukraine is an example. What is done now on the ERS, on the resilience system is an example. So this is a general appeal. So what did we do actually in London to produce this document, and today it's only document, but it's a beginning of a much bigger effort we want to engage with all of you. We brought together, it was a total of 7 former ministers. We had former commissioners in the room. We had members of parliaments, diplomats, CEOs of companies. We had head of agencies. We had banks. So we had money, we had need side. When we brought those together, it took us 6 months. And when we called them up, they said, why would you want us to be in this setting? I don't know anything about space. And we told them, this is why we want you to be there. And they came and they engaged incredibly. I have to say this was really a marvelous day. For me, it was a discovery, and we have some testimony also here in the room. When we talk about the sectors we are addressing, some were mentioned, but it's energy, it is transport, it is digital, it's all these things that really are the big things that move the planet and that are systemic for the functioning of society and economy, and Earth observation and space at large have a key role in this to play. So this is the key really of the narrative. Now, you don't do a meeting in London and it's done. It's really a task of a decade. And we want really to engage with all of you. It's also, I think, a part of an evolution of the role of ESA and some other agencies to work more closely with the policy actors, and I would add the finance community. And I don't want to take too much time on this, really, to give time for the panel. I just want to highlight something that the DG said yesterday at the 100 years of Roy Gibson and 50 years of ESA. He said, let's also take something that is a bit more on the opportunity side. Sometimes we talk a lot about crisis. Unfortunately, we have a lot of crisis, increasingly so, but the narrative has to also have this element of opportunity to help the planet, and food and water and many domains are typical examples of this. With this, I would already conclude. It's really consult the website. There are some social media posts ongoing, and I hope that this debate between space and policy is taking a new scale. We have been doing this since a while. It has been mentioned here, but I really, if you ask me today, we are at 20%, so maybe we are at the time of ERS1 if I come back to this comparison. And this is all I wanted to say as a short introduction. Again, this is what it looks like, and it is quite interesting. It's the first step, and we want to do more, and we want to involve all of you and beyond. Thank you.
Thank you, Ludwig. So let's start with your 20%, and this panel is already part of it, so we go for 21st. So, Fanny, could you please introduce what you do and what the link with Earth observation and policy making from your part?
Thank you very much. I don't know if you can hear me. I had to take off my earrings for this. So my name is Fanny Cagliano de Jong, and I work for the last 20 years in EBRD, which is the European Bank for Reconstruction and Development, very long title. And I'm currently in the climate strategy team of the bank for the last 17 years, sorry. But I'm transitioning into the space domain because I realize there's a real gap, especially in our institution, in understanding the relevance of space, not only for Earth observation, but also for business and policy. So this is actually on Monday. I'm starting my new job, so this is a scoop. So I wanted to say that for those who don't know EBRD, and of course Renaud will speak about World Bank, which is bigger, and I won't say better, but you do much more with ESA and Earth observation. But I would say EBRD has as an international financial institution, we have a very kind of niche mandate, which is to really provide support to the private sector in the countries where we operate across the industries. So agriculture, infrastructure, energy, transport, everything, financial institutions, etc. But the key thing is that our geographical coverage is very distinct as well. I know I mentioned we are a European bank, but we're not really European, so it's a bit misleading. We are owned by 75 shareholders, which includes the US, Japan, Russia, the EU. So you can see what starts happening there. And our region of operation where we can put our money, basically, and work on policy dialogue is the former Soviet Union, and then we expanded to Mongolia, Turkey. So we used to say we are from Morocco to Mongolia because we expanded also to Northern Africa, but now we're going sub-Saharan Africa as well. So I like the fact that, I think Eleanor mentioned about sub-Saharan Africa and the distinct issues or on the climate change that we will face there. This is a new domain for us as well. So I'm thinking that, yes, so it's important to mention that part of our DNA, we are technically doing a lot on green finance, and we are known also to have a very strong track record on the green finance. So we're not only an international financial institution, but we're known also to be very serious about our climate agenda. I'll just give you one number because I work for a bank, so I need to give you billions and all this. So last year alone, so in 2024, the EBRD, let's say, committed 58% of its total annual business volume towards green projects, and that's across all the region I mentioned we operate. And that amount was 9.7 billion euros of money only last year that we invested for green projects. So not peanuts, okay, not World Bank numbers, but not peanuts. So we do definitely care about the state of our planet's, health, and we want to invest, with sustainable hat in mind. So I would say yes, we care, and I think that's where Earth observation comes in, because we need to know what we are doing. We need to measure before an investment, during an investment, and after an investment to see if we've done a good job. So definitely the right place for banks is to be amongst yourselves. So thank you for having me.
Yeah. Thank you. So it brings us to Renaud Seligman. So what does Earth observation mean for you, for the World Bank Group? If you can elaborate a bit on that.
Absolutely. And good morning, everyone. So you've heard about the triple planetary crisis this morning, and it is, of course, concerning. But I'm with you in terms of the hope that we have and the sense of action that we need to have, because our vision as a World Bank Group is of eliminating poverty on a livable planet. And we actually believe that this is doable. We believe that we have had a fantastic track record over the past 30 years of actually a reduction in poverty in the world. And yes, there is a risk of stalling because of what is happening over the last 5-10 years, because of the combination of COVID, the climate crisis, the biodiversity crisis, its impact on food security. All of that is true. But there are solutions out there, and a lot of those solutions require Earth observation to be effective. So, what's clear is that what doesn't get measured doesn't get managed. And we've made a big effort at the World Bank Group to reduce the number of our key indicators from something like 140, which we used to have, to only 22. And it's in our corporate scorecard, you will see a couple of indicators that really show the importance of Earth observation. So one indicator that we've actually come up with is to measure what is the proportion of the planet, of the population, that is actually at high risk from climate-related hazards. And I'm not going to do a guessing game, but we crunched the numbers, and we found that 17.8% of the world's population is at high risk, meaning they're both exposed and they're vulnerable. They're vulnerable because they don't have the resources to deal with the implications of extreme weather events. And if you look at the map, and all of you here, I'm sure, love maps, because that's why you're here, there is a real arc that goes from the Caribbean, and Central America, to obviously the Sahel and most of sub-Saharan Africa, to big parts of South Asia, and then to the coastal areas in the East Asia and the Pacific. So that arc is the arc of maximum vulnerability. Obviously, other populations are also exposed. But you could also look at the positive side, which is the billions of hectares of healthy ecosystems. And we've also calculated that, and that's 7.9 billion. So what all of that shows is that, in order to understand what is happening to the planet, we really have to work with Earth observation. And through the Global Development Assistance Program, we've gone beyond just the understanding. We've worked with over 100 projects with ESA over the last 15 years. Those have informed something like $6.7 billion in projects. That's a significant amount of money. to give you an order of magnitude, every year the financing of the World Bank Group is about $120 billion, of which 43 billion is climate finance, either adaptation and resilience or mitigation. So it's a very significant amount of money. We're obviously present all across the world. And through those GDA-supported projects, what we are doing is that we're bringing the technology, the data, the insights, the capacity that Earth observation delivers to populations that don't have the satellite observation capacity, that don't have the data analytics capacity, but that do have very fantastic use cases for Earth observation. So we act as a connector together with ESA between the challenges and the solutions. So let me give you an example. You're here in Vienna, beautiful city, fantastic services, about 2 million people, give or take. Now, project yourself to Kinshasa, DRC. It's 9 times bigger, about 18 million people. And here in Vienna, 100% of people have access to safe water, 100% of people have access to safe sanitation. In Kinshasa, it's like the other side of the picture, right? 3/4 of the populations do not have access to basic drinking services. 8 out of 10, more than 8 out of 10 people do not have access to basic sanitation services. So it gives you a sense of what we're dealing with. Something 9 times bigger than Vienna, and then between 7 and 8 of every 10 people don't have access to some of these basic services. So obviously, we're dealing with a very significant challenge. And on top of that, a lot of flooding. Because of what we heard from the scientists earlier, you have more extreme events. Those are very, very significant in the tropics. And you really need to help manage the impact of those things. So what did we do? We worked with ESA and with GSAT, and we helped to map what actually is happening in that city when it comes to waste, when it comes to drainage network, when it comes to rivers, to erosion sites, to green spaces, which are absolutely critical to manage heat islands. And we used 300 students from the University of Kinshasa, fantastic students, were hungry for knowledge and learning and really wanted to contribute. By the way, one of the fantastic opportunities, you were talking about opportunities earlier, is that we have an amazing generation of young people who are so eager to learn, so tech-savvy, and who really want to benefit from these tools. So those students were really enthusiastic. They helped us to actually label data and to train an AI algorithm. And with that, what we got is an intelligent map with many different layers of information that allowed us to really better understand where are the areas that are high risk of flood zones, what are the critical gaps in waste disposal, what are the critical gaps in drainage systems, and to inform the design of a $500 million multi-sector operation that will actually provide safe water, sanitation, and protect 2 million people in the Kinshasa area. It's the Kinelenda project. So the bottom line is, good policies are not made in silos. They're made when you connect. And I think the panelist earlier was talking about this, about the need for people from different walks of life to come together. Students, policymakers, tech people, Earth observation, and of course the bank as a connector between all of this. So I think it's a really good match. But of course, this is just one example. There is so much more that we can do. And of course, AI multiplies the impact of what we can do.
Okay, thank you very much. And so connecting, so let's bring it indeed also to the Commission. So Dusan, what does Earth observation mean for you, and how do you embed it in the work you're doing?
Good morning. I'm Dusan Chrenek, Principal Advisor for Digital for Green Transition. My task is to ensure that we are using digital and space technologies effectively for climate action. On digital, that it's not only helping us, but also that it's green. Green digital and digital for green, really to use enabling effect of digital technologies for climate action. And the same for space technologies. In our Directorate General for Climate Action, DG Klima, we are focusing on leading the European Commission's efforts to fight against climate change and to do it on European, but also on international level. And Earth observation is key for us. We rely heavily on Earth observation. European climate policy is science-based and promoting technology and innovation. And in all three areas, Earth observation is helping us. It's a real foundation for climate science and also climate policy. Climate change is affecting all areas. We cannot do really global policies and also act in every area. We need synergy with many other players, and we need strong partners. And I am glad that on Earth observation, we have them. A good example is Copernicus. That is the best Earth observation program in the world. And Copernicus services are helping us a lot. We have climate change service, land monitoring service, and also Copernicus emergency management service that is helping to manage extreme weather events and also to provide better information, modeling, and information that is high quality, that is delivered constantly on long-term basis, and we can rely on it. And it's not only Europe, but the whole world. So for strong partners, the European Space Agency, ECMWF, and EU METSAT, so together they are working hard on Copernicus. And now we have a new project, Destination Earth, with the same partners, in order to build on Earth observation data, but also to use all digital technologies, innovative digital technologies, data centers, AI, fast telecommunication, and also high-power supercomputers. So in order to better model, to have better scenarios, and we started with 2 digital twins. So the aim is to have global digital replica of the Earth, and we started with digital twin on extreme weather events and on adaptation. As I mentioned, that we need strong partners. 1.5 years together with ESA became this joint initiative on space for climate action. And we are very happy with that. We are focusing on 3 areas: on climate science, on help of Earth observation for policy implementation, and also on innovation. And what is for us crucial, that I have now one colleague from ESA in DG Klima, Christian Recher, who is really doing what you mentioned, like really to have information sharing, synergy, and we can work closely to see what we need from policy perspective and what Earth observation could deliver. So sometimes when I'm speaking, I mean, we need like really fast and high quality monitoring of greenhouse gases. Can we get it? But they say, okay, on methane links, we can already deliver something quickly and high quality. But on CO2, we are still like working on it. We will have new satellites, constellation, CO2M, helping out on that. But it's work in progress and very difficult. And so we will have something, but we cannot get everything. So, but with the cooperation, we can advance. We are discussing other things like more better tools for cities, better tools for carbon removal certification, and we are also getting some sensitive areas like solar radiation modification, so-called geoengineering. So we have many projects that we initiated recently because of this synergy, better contacts, and I think that we can deliver much more. And what is important, to use huge amount of air observation data together with innovative technologies to scale up solutions, and also to maybe to have it more on granular level, to go to concrete cities, regions, and to deliver to them the best services.
Thank you, Dusan. So that brings us, talking about partnerships, also to UN Habitat. So for people who are not aware, today is a very good day because we had a solid signature of the memorandum of intent together with UN Habitat. So we are going to even work closer together. So please, David, how do you see the leverage of this EO data to really enhance what you're doing in sustainable development and also for the resilience in these cities?
Yeah, thank you very much. So UN Habitat is the UN agency that deals with human settlements, cities, urbanization, with a particular focus on housing and access to basic services. And indeed, we signed the MOU. This is come from a historic partnership where we've worked together on monitoring urbanization and urbanization patterns and indicators, advancing housing and informal settlements analysis, addressing the urban impacts of climate change and climate events, and also looking at infrastructure and basic service delivery, and particularly looking at spatial inequalities in which parts of the cities are underserved. Before joining our office in Europe, last 20 years I've been working very much on cities in crisis settings. Not only do we see that it's usually those informal parts of cities, those underserved areas that are often on the risk places. They might be on floodplains or they might be at risk of mudslides. So understanding that sort of risk information is critical to putting in mitigation and adaptation strategies, and particularly to the role of nature-based solutions in strengthening resilience in certain parts of the city. But what we find is not only cities responding to crisis, but cities respond to crisis in other parts of the country, because what we find is that one of the big drivers of urbanization is the migration to cities and the displacement of people into cities. For instance, in Somalia, we see in Baidoa, for instance, when there's a drought, people will move several hundreds of kilometers to a city where they feel that they can get have opportunities for self-reliance. And what we see is Baidoa, for instance, has tripled in population in the last 10 years, I think from 80,000 to 250,000, and the broader area is about 600,000. And this rapid growth is completely informal. The city doesn't have the infrastructure to be able to cope with this, so people are living in informal settlements. But what's worrying is the water table is shrinking extremely fast, and it's only a matter of time before tens of thousands of people will be further displaced from Baidoa. So one thing we're trying to do with Earth observation that I've been involved with in the Sahel, and you mentioned this sort of arc, and the analysis across 7 countries in the Sahel, from Chad all the way across to Senegal, and looking at layers of Earth observation data. So we're looking first on the shrinking of Lake Chad, for instance. We're looking then at the various droughts that are happening, the different floods that are taking place, but also mapping with that then the conflicts that are happening to understand all the sort of push factors. Then another layer of information is the urbanization, which human settlements and which cities are growing, and we can start understanding the movement of people. But then we can put on other layers of economic layers around GDP, but also economic opportunities related, say, to mining, to value addition around the mining industries, but also agriculture, value addition related to agriculture, to understand which human settlements with the right kind of infrastructure could then provide for economic growth. So when you start to look at the push factors and the pull factors, you start identifying the cities or the human settlements that could really provide sustainable growth. And then from that, you bring the hydrology analysis to see if they can really cope with growth. Do they have the natural resources and the water able to do it? Once you do that, you're moving from a reactive urbanization approach or reacting to the impacts, the often negative impacts, to an anticipatory approach where we're working with IFIs to then try and encourage investment in critical cities that can accommodate growth, and so that you're building resilience, but you're also generating the economic values of urbanization. So Earth observation, I think, is a game changer for us. It brings us from a reactive approach to an anticipatory approach. Thanks.
Great, thanks. So back to you, Fanny. So we're talking about figures because you're a bank, and so we're talking about a lot of the green finance. So which activities, to your opinion, should ERBD and ESA embark together to really have even more uptake in the private sector for these analysis and decision projects? So how do you see that?
So we do, as I said, invest across the sectors, right? But I wanted to say perhaps the sustainable infrastructure and investing in cities is a big domain for us as well. And I want to mention we have a flagship program called the EBRD Green Cities. Sounds very exciting. But essentially, that's where we started. And we've got a couple, I think, right now we have 3 pilots with ESA. We've started actually collaborating already under the ESA GDA program, one of which is going to support our green cities indicator monitoring. So I see that as a big, exciting potential, because if you can show with one city what you can achieve with Earth observation, then you hopefully can replicate and scale up to all the other cities. We're about now 65 or 70 cities signed up under our Green Cities program. So that's an element where I think we can work together. But I wanted to resonate on what Ludwig said earlier, because I think for us to understand first, we're still infant stage, I have to say. We are still in the beginning of that journey of understanding how it can help us do our business. But what Ludwig said about that vision paper on Earth observation, and we were very happy, of course, as EBRD to be participating. Maybe it's because we were in London already, so you thought, okay, you can come along. But I really like the fact that we were able to break down what it actually means, Earth observation and support to different sectors, for the municipalities, for the governments, for the banks like ourselves. And that vision will provide also something to show for to our clients and internally to our own different heads of departments when we talk about food security. I mean, we operate in Ukraine as well. Right now, it's part of our region of operation. Food security, energy, transport, diplomacy. I mean, I mentioned the map where we operate. So we need all of that. So I think the collaboration we are building now with the European Space Agency and specifically with the pilots under GDA and working with colleagues in SP, but also with other IFIs like the World Bank and ADB and African Development Bank, etc. I think for us that community is priceless, because we can learn from each other. We don't have to start from scratch. We don't have to reinvent the wheel and waste time or resources. We can combine and align resources, align ideas, and hopefully build bigger things together and have more impact. So I think there is a lot to be done with Earth observation. And back into my little world of EBRD, of course, I mean, we've been set up, for many years, since 1991. Probably when your son was sleeping in your office. So we transitioned. We had a lot of big, mandates as a bank was initially to transition all these countries to market economies. But now our objectives, our core objectives, are first green transition. That's our main objective. Then, of course, we have human capital. We rebranded recently. We call it human capital. But it includes, equal opportunities for all. It includes gender, youth, it includes a lot of this access to water, as you said, access to, education. So that's that's another objective. And then finally, economic governance, where policy comes in again. So I think we don't just do investments, we also do policy dialogue. But ultimately, I think data and science, now more than ever, because those are facts, we cannot deny it. And, you don't have to take sides, you don't have to talk about borders with science. I think that's where we need to work more together.
Yeah, thanks very much. So also back to you, Bruno. So you were also talking about the concrete examples. You have gave Kinshasa. So we also know you work a lot with governments. So how, to your opinion, agencies like ESA and other space agencies can really contribute effectively? And so one of the things in your view, what is then a balanced approach also to encourage the public and the private sector?
Right. No, that's a critical point. But of course, you have to put yourself in the frame of mind of thinking about the client countries that we are dealing with, right? So I talked about DRC, but you could talk about South Sudan or about Sri Lanka or other countries slightly higher up the income ladder, middle income countries like Mexico, Indonesia, Brazil, India, China. So, they are at very different stages in relation to the Earth observation value chain, right? Some have nothing. They don't have satellites, they don't have data analytics and Earth observation capability. They have challenges that could be tackled with Earth observation. They don't have the ecosystem. Others have launched their own satellites, Morocco, Argentina, etc. Right? So there's a whole spectrum of countries that we are dealing with. But what's common across the spectrum is that a few things are really important. One, trust in the data. Two, relevance of what is provided. Three, making it user-friendly and usable. People in government policymakers do not care at all about data sets and about very complicated ways to access them. They need to have the data distilled in a way that is usable and that is relevant to the challenge that they are facing. So that requires some work, to bring it to that level. And of course, that work has to happen at the sectoral level in terms of engaging with policymakers in Ministry of Forestry or Ministry of Agriculture or wherever it is that the issue needs to be taken. Of course, Ministry of Finance. More and more there is space to work about to embed geo mapping in public investment management to ensure that, for instance, the climate resilience dimensions are well taken on board. And of course, that those layers of information come together. But I think where we are now, in the case of the World Bank ESA partnership, is that we've gone beyond the piloting phase, and now we are going to the scaling phase. So how do we scale? Well, it needs to be affordable. It needs to be accessible. We need to transform Earth observation as a bit of a commodity that gets embedded, in the project cycle. And there is space for both the public and the private sector on this. Let me take an example from the public sector, and let me talk about the private sector very quickly. So, from the public sector side, the panelists earlier talked about some of the success stories with tropical countries and forests. I think that's a really important point. There has been massive progress in places like Brazil, Indonesia, countries that are now monitoring their forests much better from the sky. But of course, there needs to be even greater progress because there is not yet full trust of the market in, for instance, carbon markets coming from forestry, carbon credits that are issued related to forestry. There's a trust deficit. So if we could maybe use the future data from the biomass program of ESA to increase the level of trust, to show that actually you can not just measure the canopy, but you can go beneath the canopy and measure what's happening underneath, and to give confidence to the marketplace that actually, this is bona fide, right? And this is really has integrity. I think that's a very, very useful frontier that we can work on together. Similarly, Brazil is working with many other countries and with the World Bank on something they call the Tropical Forest Facility Forever, which is about providing payment for services for standing forest, standing tropical moist forest. Well, you need to be able to monitor with integrity that indeed that forest is standing. So again, you cannot do that without good, solid Earth observation, right? And it needs to be credible. So I think that's an area where the public sector definitely has room to grow. I think on the private sector side, one thing that is very exciting, I've been circulating in the conference, and the ecosystem of startups and private sector companies is very exciting. There's a lot happening here. But there is also the potential to create a very vibrant private sector in that space in developing countries. You know, it's already happening in China, it's happening in India, it's happening in Brazil. But why is it not happening so much in Ghana or in DRC? Or there is a space to really think about how do we nurture that ecosystem very intentionally in the countries where we are active, so that it's not just the public sector side that grows, but also the private sector side that creates jobs. And I'll leave you with one statistic to finish. You know, there are 1.2 billion young people that will come to the labor market within the next 10 years. About 435 million jobs are going to get created by that time. So you have a gap of about 800 million people who will not have a formal job in the developing world. The bulk of those are going to be in Africa. So we've got to roll up our sleeves. We need to work with African countries to really create the job opportunities of tomorrow. Those are going to be, of course, in part, in the tech sector, in AI, but also in Earth observation. And we need to think about how this can turn into an opportunity for many, many countries in sub-Saharan Africa.
Thank you so much. So we're running a bit out of time, and I know people have to go to other sessions, but I just want to finish with Dusan and David. Could you just give us very shortly, so what are to your opinion, the most critical things we should work on, so the gaps for the uptake and the adoption? If you have some good ideas.
There are many gaps. Like we are really working on a number of issues, so also on carbon credits, on certification of carbon removals, nature-based solutions, but also industrial solutions. So that's one area. On mitigation, on decarbonization, also we need Earth observation data for renewable energy, for transport, buildings. That's useful everywhere. And one area that now we are focusing a lot is on resilience, preparedness, adaptation. So next year, the European Commission will adopt European Climate Adaptation Plan. And now we are looking at how we can use technology, satellites, existing, but also future satellites, because it's really good that ESA, EUMETSAT, primarily Copernicus, we are going to have new satellites. Biomass, recent example, EarthCare last year. So we need to use it, and we need to use for the benefits of all. And in Europe, now we would like to really replicate and scale up. For cities, we have hundreds, maybe thousands good solutions that are used in 1-2 cities. We need to replicate, to scale up for like canopy, for urban heat islands, also for renewable energy. There are many good things that we can replicate. And not only in the EU, but also outside. And learning from experience with ESA, we replicate. So now we will have a national expert from German development agency, GIZ, trying to have similar successful cooperation. And what we are developing in Europe, also trying to use in other regions to help other regions to tackle climate crisis and to be ready. So we need to prevent disasters, protect people, but also prepare them for future, because definitely, as all reports are showing and calling for action, global warming is not going to stop. No. And there will be more weather extreme events. And also we need to prosper, to be resilient, and to support innovation. And for us, Green Deal is a growth strategy. Really, innovation, new technologies, guaranteeing that life on the planet is becoming cleaner and better. And I think that we are leading on climate. And now I'm sure that we will be leading also on space for climate action.
Great. David, from UN Habitat.
Yeah, I think from our side, there's an ever-growing need for more high-resolution Earth observation data. I think we can see general trends. Of course, we can see, for instance, with heat island effects, reduction of green areas, climate change, and the heat islands. We can see the correlation, but there's a real need then for that sort of granular, more high-resolution information to be able to understand what kind of actions to take. Where do we need to really concentrate more green areas? Where do we need to look at the airflow and other things? So I think the granularity of Earth observation data is going to be really important. I think the technology, because really what the analysis is when you can bring several layers of information together. And I think having applications that can bring different layers of analysis together is going to be really important. And of course, our focus is developing countries. Often there's limited capacity in a lot of countries to be able to use Earth observation data, even if it's available. So a huge effort on capacity development. As you mentioned, there are young talent, there's educated people, there's a lot of opportunity there, but I think there's a need for that training so that we can make use of Earth observation and use of the talent that's available in developing countries to use it.
Thank you so much. So I'm afraid we're a bit running out of time, so we really have to close this panel now. So I really want to thank the audience. Of course, first of all, also thank to all of you. Don't run away immediately, because we do have the QR code of the nice work done by Ludwig and his team. So I think they're going to put it on the screen now. I have to do it.
There it is.
There it is, yeah.
Yes.
So thanks again to all, and please download this very nice work done by SP, and I'm sure Ludwig, you're around here today, so if people have still questions for the panel, we're here to help you. So thanks again.
Great to meet you.